Good evening, everyone. My name is Grace Dobush, and I will be guiding you through this event this evening. Before we get started, I'd just like to remind everyone to set your devices to silent mode, but we encourage you to take pictures, post on social media if you like throughout the evening using the hashtag AWIPEV. Tonight, we are broadcasting live around the world via YouTube from the French Embassy in Berlin. And we are celebrating the 20th anniversary of the French-German research base AWIPEV in Ny-Ålesund in the Svalbard archipelago of Norway, which is nearly 3,000 kilometers north of where we're sitting right now. The station is operated by the Alfred Wegener Institute's Helmholtz Center for Polar and Marine Research in Germany and the French Polar Institute Paul-Émile Victor. AWIPEV is a crucial research location for French and German institutions. The impact of climate change in the Arctic is nearly 4 times greater than elsewhere in the world, and the region around Svalbard is among the warmest areas of the Arctic. Tonight, we will highlight findings from the past 2 decades of research in 5 short lectures. And to celebrate this collaboration, the directors of the Alfred Wegener Institute and the French Polar Institute will sign a memorandum of understanding. We also will be joined by the station staff in Ny-Ålesund live via video, and they will be able to answer your questions. And we will wrap up the evening with a reception in the foyer where there's also a photo exhibition. So now, to kick off the event, I would like to invite the French Ambassador François Delattre on stage to officially open the event.
Quel immense plaisir, mes chers amis, de vous accueillir ce soir. Dear Professor Boisius, Director of the Alfred Wegener Institute, cher Dr. Robert Couder, directeur de l'Institut Polaire français, Paul-Émile Victor. It means the world to me, and I know for all of us here tonight, to have you both for us and with us this evening. Dear Mr. Lagrange, représentant du ministère de l'Enseignement supérieur et de la Recherche, formidable de vous avoir. Dear Mr. Ripken, representative of the Bundesministerium für Bildung und Forschung, if my pronunciation is okay. So it's truly an immense pleasure for our scientific counselor, Pascal Revel, and his team, and of course for me, to welcome you tonight to the French Embassy on this very special occasion, as we are gathered here this evening to celebrate 20 years of quite extraordinary French-German Arctic research through the 20th anniversary of the AWIPEV Arctic Research Station. And let me begin by expressing my gratitude to the Alfred Wegener Institute and the French Polar Institute Paul-Émile Victor, as well as all those present here with us who have contributed to the establishment of this important and in many ways exemplary Franco-German scientific initiative. On this special day, I'd like to pay also tribute to a man who have marked the history of polar and climate research. In March 2023, we lost a French pioneer, a visionary scientist, the glaciologist Claude Lorius. His revolutionary work on ice cores in Antarctica made it possible to retrace the climate history of our planet and paved the way, as you know better than I do, for many important discoveries. So our thoughts are with him and for him tonight and with his family. The AWIPEV station was founded in 2003, and the research conducted at AWIPEV has truly deepened our understanding of the climate, its mechanism and its consequences, while highlighting the urgency of acting to preserve our planet. In this respect, this collaboration this exemplary collaboration of yours, that France, reflects the fact that Germany and France together are at the forefront of international efforts to combat climate change and to preserve biodiversity. I experienced it first rank when I had the honor of participating in the COP21 negotiations that led to the Paris Agreement. And there I could really see first, at the front line, that Germany and France together were kind of the bridge that brought together China, the US, and then the international community. And that was the Paris Agreement. That is a milestone in this fight. But of course, it's not the end of the story. And now it's up to all of us to join forces and to go, of course, a step further and to convince the financial community, the enterprises, and all of the civil society and the governments to join us in this existential fight against global warming. And as we celebrate the 60th anniversary of the Élysée Treaty, as we are also about to welcome President Macron for a state visit here in Germany, early July, France and Germany share a strong and common desire to carry out joint research projects, and the AWIPEV station embodies truly this ambition perfectly. French and German scientists are working hand in hand, braving, as we could see on the video, extreme weather conditions to achieve their common scientific goal. Their commitment and dedication are second to none, and we celebrate them today for their outstanding contributions over the past 20 years. So let me express both my gratitude and encouragement to all the French and German scientists and other professionals who are part of this joint extraordinary endeavor. Warmly thank also the many speakers for agreeing to present their research this evening and to discuss with us, with a special word of thanks also to the scientists joining us online from the station. Je suis absolument ravi de vous accueillir tous. Merci d'être venus aussi nombreux. Et je suis plein d'admiration devant ce que vous faites tous les deux et tous les cinq. Et comptez sur mon soutien et celui de la France. Merci de tout cœur.
Thank you very much. And now Olaf Ripken, head of the Marine, Coastal and Polar Research in the German Ministry of Education and Research.
Your Excellency Ambassador Delattre, dear Monsieur Lagrange, dear colleagues from AWIPEV and AVI, dear ladies and gentlemen. Bonsoir, guten Abend, good evening on behalf of the Federal Ministry of Education and Research, BMBF. My name is Olaf Ripken from the Division on the Marine, Coastal and Polar Research from the BMBF. Previously, I was in the EU division in our ministry, and there I was closely working together with our French colleagues negotiating Horizon Europe. So I've always been in close contact with parts over there and have excellently cooperated with them. 60 years ago, the Élysée Treaty has been a crucial cornerstone really of this German-French friendship and the cooperation in so many areas. AWIPEV is really one of the perfect examples for these joint activities. Today, we celebrate the 20-year anniversary of this joint research base in Ny-Ålesund. Thank you also for the Norwegian hosts. The German federal government has recently published the Future Research and Innovation Strategy. It's also about exploring, protecting, and sustainably using oceans and polar regions. This is one of the 6 missions within the strategy. And there, research excellence, interdisciplinarity, and international cooperation are really key tools to achieve this particular mission. And one can just notice that AWIPEV is really ahead of its time, because despite its 20-year existence, it fits perfectly into this strategy, which has now recently been published. The AWIPEV Blue House is a lighthouse of cutting-edge research on climate and biodiversity. Both crises can really threaten our very existence. The Arctic warming is even faster there than in the rest of the world. So this underlines particularly the importance of the work of AWIPEV. Tonight, we are looking forward to exciting insights in the work of AWIPEV. All the best for the future from my side, from the ministry. Thanks a lot for this opportunity.
Thank you very much. And now, Alain Lagrange, Head of Marine and Polar Sciences at the French Ministry of Higher Education and Research.
Mr. the Ambassador, Director, dear colleagues, for the French Ministry in charge of research, I am very pleased to be at the French Embassy in order to celebrate a wonderful birthday, 20 years of successful collaboration between two organisms, the German Alfred Wegener and the French Polar Institute Paul-Émile Victor. First, I would like to apologize Claire Giry, our French Director General of Research and Innovation. She asked me to say a few words. If 20 years is the age of enthusiasm, it is also the age of first assessments. While the choice of bringing together two scientific partners from France and Germany to create this Arctic station was a logical decision, it has also proved to be a relevant decision and, above all, a successful decision. In fact, the AWE and the AWIPEV are two institutions that are very active on the international scientific scene, frequently collaborating together in geographical areas that are not restricted to the Arctic. They defend common positions and values in various international institutions. This beneficial pulse has encouraged the emergence of an Arctic priority in our research program with the launch of various calls for projects. This beautiful site deserves more and more greater recognition from French scientists. In the coming months, we believe it is very important to promote this exceptional site within our community by strengthening and diversifying high-quality research programs. More than ever, the Ministry of Research is committed to increasing and extending the quality of the cooperation between our two organisms in order to better serve our two scientific communities. Thank you for the attention.
Dear Ambassador Delattre, Mr. Ripken, Mr. Lagrange, Professor Boetius, Mr. Robert-Cordaire, ladies and gentlemen, in the name of the organizers of the event, as well as the following speakers, I'd like to officially welcome you to the 20-year anniversary event of the German-French Arctic Research Base, New-Ålesund. And very special thanks go to the French Embassy for hosting this event this evening. We'll now dive into 5 presentations, and at the end of all 5, altogether, we'll have some time for questions and answers. So to start, I would like to invite Roland Neubert and Frank Delbar to the stage. They were the coordinators of the German and French stations in New-Ålesund. Since then, Roland has retired and Frank is working in a different field, but there's no better experts to tell us about the creation of AWIPEV. Welcome.
Stop. It's time to drink. And this is. Mesdames et Messieurs, meine Damen und Herren. Frank and me have prepared for you this little introduction to the AWIPEV research base in order to set the stage for the following tasks and the celebration. Let me start by taking you back 20 years to the exciting times early of this century, which was a time when borders had been opened and new opportunities and cooperations were appearing everywhere. Polar research had traditionally been conducted on national levels, but in these times, international cooperation was booming. In the little village of Ny-Ålesund, you see the picture here, on the west coast of Spitsbergen, a small international research community had been established by Norway, where, among other nations, France and Germany were running their Arctic research stations. It was there where Frank and I met for the first time, being responsible for the operation of our respective research stations. Ny-Ålesund is a special place. Many of you here in the audience who have been there know this, as our Norwegian hosts provide not only the buildings, which you see on the picture, but also the food and the provisions. Everyone in the village is eating in the same restaurant 3 times a day, bringing together people from a dozen nations. This promoted also French and German scientists and logisticians to meet casually, exchange experiences and ideas, and to help each other on various occasions, with tools, instruments, or just by giving a hand. At the same time, the then directors of our institutes, Professor Jørn Tide of AWI and the founding director of the French Polar Institute, Dr. Gérard Jugy, had started several cooperations of our institutes for research in the Antarctic and were planning for coordinated European polar research initiatives on various levels. One of their ideas was to make a special showcase for a cooperation, a jointly operated polar research base. This was likely to be the very first time and quite unusual. It was at the Arctic Science Summit week in March 2003 when Jørn Tide and Gérard Jugy told Frank and myself about their idea and asked us whether to merge our stations in Ny-Ålesund. I remember that we just looked at each other and said, sure.
No troubles.
In the year 2003, as was mentioned, the Élysée Treaty, who had sealed the friendship between France and Germany, had been signed 40 years ago and was to be commemorated in several events. One of them was the visit of the German research icebreaker Polaire in the French harbor of Brest, where the AWIPEV is located. It was there where Jørn Tide and Gérard Jugy signed a document, you see on this picture how they do it, which described what Frank and I were supposed to do, to organize the joint French-German polar research base in Ny-Ålesund.
Okay, so as we share everything, then I go on. Sorry, that's in English. I'm very sorry. So for those who've never been to Ny-Ålesund, let's have a look on the way to go there. And if we start by plane from Paris or Berlin heading north, the first stop is in Oslo, of course, the capital of Norway. And from there, direct flights carry you to the archipelago of Svalbard, and which is halfway between Scandinavia on the North Pole and already way above the Arctic Circle, which is located at 78 degrees north. The main town there is Longyearbyen, you see, in the center of the island called Spitsbergen, where these flights arrive. From there, there is just a small hop to reach the Ny-Ålesund community on the west coast of Spitsbergen, located in the lovely Kongsfjord. There, our stations comprise an observatory building and 2 houses with offices, bedrooms, workshops, of course. And at 5 kilometers from there, close to the Leuven station, there is this remote station, which is named the Korbel station.
It turned out that an important detail was quite advantageous for our task to join the stations. The research topics that had been pursued at our individual stations had been very complementary. There was little overlap. While French scientists worked mainly on land, investigating glaciers or birds, German scientists studied the fjord and the atmosphere. Accordingly, our logistical facilities were complementary as well. For example, AWI had established a comprehensive atmospheric monitoring program at the observatory, while AWIPEV was running the Corbel station close to the Loven glaciers, which were the main target for French glaciologists since decades. So Frank's and my task was to merge our various and quite distributed facilities into one research base, where our guests should not be able to differentiate which part was provided by which institute.
Yes, all right. I fully agree still. So first, then, we wanted to mix the French and German staff. That was not a difficulty at all. That was very nice. And to form our joint overwintering team, on which are annually recruited, We prepare the teams each year with the joint introduction program. In Nyalusund, the joint base is represented by our base leader for the local community, administration, and the visitors. We also began to represent the joint base alternatively for the Nyalesund's Managers Committee Coordination Group, which is NISMAC, which meets twice per year, one time by Roland,
And the
other time
were you?
Yeah, for sure. And then this was a very nice exercise to speak on behalf of each order. It required some preparation from some delicate points when we really needed to have the same view about them. We had to speak in the same voice. So it wasn't difficult.
It was not so difficult.
So this means also that we needed and deeply know about the various projects from the other institute, and this opened us a nice vision of potential collaborations. We set up a series of scientific seminars, of which the first was hosted at the European Polar Board in 2003.
Yeah, at 2005. Well,
okay. Okay, in Strasbourg.
yes.
Yeah. So as to confirm for improved collaborations in between the two countries. Concerning the field operations, we merged the logistics together so as to run scientific projects efficiently and safely, of course, with the help of Norwegian. The teams have to roam around in Nyalesund on the Kongsfjord area using all sorts of transportation, as you can see here. The Blue House is the headquarters of the AWIPEV station, Robot Station, the center for the mechanical and the logistics. Dog sledges, yeah, also, sometimes. Yeah. 2 annual meetings are established for the preparation of the season, to be held in spring, and for organizing the joint activities, logistics and budget in each fall. A new website was developed illustrating our cooperation and providing practical information to our guests. We want to mention there that at the foundation of the success, which the idea of the jointly operated Polar Base AWIPEV has experienced, are the people who picked up this idea and lived for it in their daily work. That was very important. The many overwintering teams, which had the pleasure to form and guide, thanks to the field team's involvement and efficiencies. Field equipment is available all the time also for science in summertime as in wintertime. But the success of AWIPEV is also based on the limited but dedicated personnel at institutes at AVI and IPEV. They continuously support the teams on the operation on a daily level, to manage ticket, flight ticket, budget, etc. Thanks to that. And then there are many of those people are here today. Then we really want to thank all of them. In the aim to share with the community of Near-Lausanne a clean base for especially snow chemistry researches, the buildings of the Corbel station at 5 kilometers were fully rebuilt in a typical Norwegian shape, we try to, and equipped with an electrical power supply completely relying on renewable energies. The sun during polar day and a windmill during polar night, thereby limiting local pollution and making the station autonomous.
So, to the end of this introductory presentation, let us briefly hint to the research topics which are at the core of the AWIPEV operations. They were mentioned in the film as well. The overall theme of the research topics can be summarized as the study of climate change processes as such and its impacts on the living conditions for all species, from the microbial communities in snow and water to the higher levels of the ecosystem, which we find in the Kongsfjord area and beyond. In order to assess climate change, long and stable data sets are mandatory. To have a base like AWIPEV running for 20 years, all year round, is the foundation of any statement about how and why our climate is changing. The most prominent indicator of climate change is the air temperature. For several years already it had been known that the Arctic is warming faster than the rest of the globe. This slide, which you see here, shows on the left side the temperature trend in the Arctic. The darker the color, the stronger is the warming. On the right side, the map shows the degree to which this trend in temperature on the local basis is stronger than the global mean. This is the base for the statement which we heard already at the introduction, that the Arctic is warming 4 times faster than the rest of the globe. And as you can see in the white circle, Ny-Ålesund and Spitsbergen is right where these changes are strongest. We are right at the hotspot of Arctic climate change. Merci beaucoup pour votre attention et à nos collègues et administrateurs un sincère merci pour votre soutien et votre dévouement.
Und vielen Dank für Ihre Aufmerksamkeit und unseren Kollegen und Direktoren ein aufrichtiges Dankeschön für Ihre Unterstützung und Ihr Engagement.
Thank you so much. To speak about atmospheric research, we have next Dr. Marion Maturilli, the Alfred Wegener Institute's AWIPEV scientific coordinator. She has a background in meteorology and atmospheric physics and has been head of the AWIPEV Meteorological Observatory for almost 20 years. Please, welcome.
Thank you and good evening. As you have just heard, Svalbard is right in the center of the climate warming. And I'm going to talk to you about the atmospheric measurements at AWIPEV and how they detect the pulse of climate warming. So we're starting with the annual mean temperature at Ny-Ålesund, shown in this graph. We do obtain that since the early 90s, and with a simple linear regression, we can see that there is an increase of the annual mean temperature of 1.2 degrees per decade, which is roughly the number that you have seen before in the overview map. However, today I would like you to focus on the winter time. And winter in this definition refers to December, January, February, and you see that in these red dots. I need to adjust the scale here a bit. On the first view, you can directly see that there is a large spread of these data points. So there is a large interannual variability. However, there is also a positive trend or an increase in temperature concerning the winter month. And that actually is 2.2 degrees per decade. So the winter is actually warming even stronger than the annual mean. So why is the winter season so affected by the warming? And just consider that during winter in Ny-Ålesund, we are in the middle of polar night, so there is no solar radiation involved. I'm here showing you a map of sea ice concentration of December 2022. And in this red circle here, you find the location of Svalbard. Close by, there is also a light blue line that indicates the sea ice edge in older times. So the sea ice edge in the years 1981 to 2010. And just east of Svalbard, you see that where there used to be ice, there is now the dark blue color of open ocean water. So in the vicinity of Svalbard, especially over the Barents and Kara seas, there is now open ocean where there used to be sea ice. And that, of course, has implications also for the atmosphere. The Arctic air is cold, and compared to that, the ocean temperature is relatively warm. So in between atmosphere and ocean, there is the sea ice as a layer of isolation, but with the diminishing sea ice, there is transport of heat and moisture from the ocean into the atmosphere. And that, of course, warms the atmosphere from below. And then the atmosphere, of course, is not limited to the surface, but it stretches into the vertical. And we see here that there is an increase of moisture that has also an effect on the clouds. The properties of clouds are changing, and that influences the thermal radiation going down to the ground, or more or less the local greenhouse effect. So there is additional warming from these layers in the atmosphere down to the ground, contributing to the Arctic amplification of climate warming. And since the atmosphere is dynamic, there is also air motions, especially in the upper parts of the atmosphere. So these effects are not just limited to the Arctic Ocean, but they can also be observed over land, for example, over Svalbard with our measurements at the AWIPEV research base. And here we're now looking at the weather balloons that we are launching at AWIPEV since 30 years already. Small instruments, so-called radiosondes, that measure temperature, humidity, pressure, and wind, while they ascend on a balloon into the atmosphere to reach roughly 30 kilometers. And from these measurements, taken every day since 30 years by now, we can actually derive a temperature trend also for the vertical column. And this is shown in this nice plot, which is specifically for this occasion kept in the French national colors. We're now looking at the temperature trend from the ground to 8 kilometers over the entire year. So from January on the left to December on the right. And these are the monthly values. And I want to point out that only these color bars that are surrounded by black lines are actually statistically significant trends. On the first glance, you can see that the temperature trend is not uniformly distributed over the course of the year, and it's also not uniformly distributed over the vertical axis. As before, I would like to focus on the winter month. So we're again now with December, January, February. In particular, as January is really the month which sees the strongest warming. Close to the ground, we observe an increase of temperature of about 3 Kelvin or 3 degrees per decade. So that is really a very strong signal. We see that there is a bottom amplified warming. So in all of these months, the warming is strongest closer to the surface, and that is due to the processes that I've described before. So the heating from below, but also feedback mechanisms from upper parts of the atmosphere. Yet there is also a warming that stretches out through the entire troposphere. So these 8 kilometers that are really the area where the weather occurs. So that is where dynamical processes are occurring, and changes in atmospheric circulation lead to changes in the temperature in these altitudes. So changes in atmosphere circulation means different air masses are observed. So where do these air masses actually come from? And we find that in recent years, the air masses, they do come more often from the North Atlantic region, and that this is related also to a more frequent occurrence of a blocking height over the Scandinavian and Jura mountain regions. And in this graphic shown here, you see the mean sea level pressure in winter in gray background. And on top of that, there are red and blue lines indicating high and low pressure anomalies occurring in these cases when we do see air mass transport from the lower latitudes or from this North Atlantic region that is indicated with this white box here. So this is actually referring to low pressure anomalies over Greenland and high pressure anomalies over Scandinavia and the Ural Mountains. And that is a pressure pattern that is observed more frequent in recent years, leading to this increased transport of warm air masses from the lower latitudes towards Svalbard, the Fram Strait, and the so-called Arctic Gateway, or gateway to the Arctic. Right, so where does this come from? So why do these pressure patterns occur more often? This is again related to the picture as you've seen before. So there is heat and moisture input over the Arctic Ocean in these regions where there used to be ice. Of course, with that input from below, the atmosphere is warming and there are changes in the atmosphere occurring. So the stability of the atmosphere is changing, but also the pressure, and that at the end feeds back into the general atmospheric circulation. So, well, you could say that the retreat in sea ice is actually affecting the atmospheric circulation and also the pressure patterns that are observed in the Arctic and also in connection with the mid-latitudes. And at the end, this leads to more cyclones being transported deeper into the Arctic and passing over Svalbard. So what does that look like if a cyclone is passing over AWIPEV station? Here's again measurements from our weather mast in January 2022. And yeah, that's the temperature. You could guess there is some sort of baseline of the temperature around maybe minus 12 degrees. Yet there are these pulses of warm air, and that brings back the title, the pulse of climate warming, because these are actually cyclone events that bring these warm and moist air masses to Svalbard and do have an impact on the local climate. So this is the contribution by atmospheric transport to warming that we observe at Ny-Ålesund. And I want to point out that some of these cyclonic events lead to temperatures being above 0 degrees, so above freezing. And then it happens that the precipitation actually occurs as rain. So in the middle of winter at Svalbard at almost 80 degrees north, it's raining. Right, and then after these rainy events, the temperature drops again. So what was liquid on the ground is then freezing. And this is a picture I'm showing you here. So we then observe thin ice layers inside the snow. And actually with this, I want to take you from the atmosphere to the ground and would like to hand over to the next speaker. Thank you.
Thank you very much. And to address permafrost, we have next Professor Julia Boyke of the Humboldt University in Berlin. She leads Alfred Wegener Institute's group on energy and water fluxes in permafrost. Eric Bernard, I'm so sorry. So sorry. Yes, I was getting ahead of myself. Thank you. To speak about glaciology, I'd like to welcome on stage Dr. Eric Bernard, a CNRS researcher at the University of Franche-Comté. He is regularly at AWIPEV to continue the long-term monitoring of glaciers in the vicinity of the station. Welcome.
Good evening, everybody. I was not in a hurry to speak, but I think I can make the link with you, Marion. Thank you. So my topic tonight will be more about glaciology topics. And well, I will go a little bit more quick on that topics because everybody talked about that. From a glaciological point of view, it's very important to work in Arctic because it's warming faster. And as Marion told us, it's become wetter and wetter. So it happened that in the middle of the winter and during all the season, we can have some rain events on the snow, on the glacier. And that's very important with, you know, the dynamics, further dynamics on the glacier. That's we will see after. So here we are in the west coast of Svalbard. We work on this small basin. You can see here it's 10 square kilometers. And what is important here is that there's a calcareous bar and we can monitor nearly mostly everything in the glacier and in the whole basin. That's something very interesting for us to have the whole source to sink dynamics. And of course, we are. I am part of one of the lucky team staying in the Corbel station, so we can go very quickly on the field to work. Well, we have monitoring since 2008, and this is very important because, as somebody mentioned, it's very important to have long-term measurements. And in this measurement, mainly one which is very important and major is glacier mass balance. Basically, the mass balance is the budget of the glacier, the difference of ice loss and ice gain. And it gives a trend of the glacier health, I would say. And this indicator is widely recognized as very sensitive to climate changes. And what I would like to point this evening is the evolution during the years of observation. If you have a look here on the 5 first years, you can see the glaciers, some normal situations pointed with a blue arrow, and 1 year which was something very unnormal, I would say. And this was pointed in 2010. But if we continue further, the 5 next year, we can see that also with a red arrow, the glacier, what was something unusual became more usual, and there is few blue arrow, which was something normal with an equilibrium lane and so on. So it became like this, and more striking is 5 last years, where you can see the accelerating rate of melt, and you can see that with the red arrows, a situation which was something very unusual became finally normal during the 5 last years. So that's one of the most striking results. And you can see that on these small maps, there is no more accumulation on the glacier, or only in a few parts of the glacier. And why this is so important, I make a point with the presentation of Marion, is because of the winter. Winter is actually a key season because we have some rain and snow events. And on the picture on the right, you can see taken from the Zeppelin fillet over New-Ålesund. It's still snowing up on the mountain, but on the sea level, we have lots of rain creating some snow swamp, and with the pulse of refreezing, we have some ice layers into the snowpack, and this is, I would say, something which trigger highest rate of melt, of snow melt, and this is very important because it's not only glaciers which are widely known as indicators, but it's a whole south to sink system. I mean, from glacier to the fjord. Here, for example, if I take the only example of one stake, measuring the ablation or the accumulation of the glacier, we have in 2021 an accumulation of 146 centimeters, but what is important here is that we lost 29 centimeters in only 1 week during a warm event, and this represents more or less 20% of the annual mass balance. So it highlights how are the consequences of such warm events on the glacier mass balance. And of course, we can see on the landscape what happened with the front, which is an evidence of glacial retreat. And you can see here in between more or less 10 years, there's a retreat of 100 meters, which is something quite important for considering the size of the glacier here. And these dynamics directly conduced by glacier melt is the periglacial dynamics, with, for example, the sudden and violent process like discharge that we can see into the moraine. But more interesting is the sudden and violent floods that are directly linked with glacier melt and liquid precipitation. Here on the left, you have the situation in October, and it was nearly freezing, but in a few hours, the temperature rose and everything started to melt, rain plus melting of the glacier. And if we put this in a map and with a calculation of differences between the two situations, we can see that the sediment budget here, it's only in a 5 years period, sorry. We have 1/3 of the sediment which are deposited downstream. It's what is pointed on green on this map. And the 2/3 of the other sediment are directly flushed into the sea. And this changed a lot the structure and the reshaping of the periglacial environment. Indeed, we have massive afflux of sediment into the fjord, and this reshapes completely the shore and the coastline. And we also have this afflux which lasts during the whole season, drawing a new shoreline and changing completely the water circulation, the water system. And what is important here is to re-put the glacier studies into the whole system. As I talked before, it's a source to sink system. Is what comes from the glacier and going to the sea. And we measured lots of changes due to this increase of erosion, increase of runoff, and this material transfer are influencing the whole biotic and abiotic environment. And this geomorphological reshaping, water and coastal evolution, and periglacial adaptation are actually processes that we bear witness seasons after seasons, and things we are measuring during all our stays here on the field. Okay, so just one word to say that science is not something we are doing alone. So I would also like to thank the team I am part of, the team from Corbel, and thanks for attention.
Thank you. And now to address permafrost, we have Professor Julia Boyke of the Humboldt University in Berlin. She leads Alfred Wegener Institute's Group on Energy and Water Fluxes in Permafrost Landscapes and is the head of the AWIPEV Permafrost Observatory. Thank you. Actually, I switched, but sorry, here we go.
So welcome everybody. My talk will be about permafrost, and I'm working since 1997 on the permafrost areas in Ny-Ålesund, and I will present data for about 25 years of record now that we collected at this site. So first of all, what is permafrost? It's part of the cryosphere. It's the land, basically, that is not covered by glaciers. So here you see the picture of Ny-Ålesund, you see the village of Ny-Ålesund, you see the airport, and everything there, the land, is basically underlain by this frozen material that is below 0 degrees. And you see the red star here, this is the Bayelva Permafrost Observatory, where you can actually take the bicycle to halfway, which is very nice from the AWIPEV station. And in the following now, I will go through the changes that happened at the site and how do we document these changes. So permafrost is a subsurface phenomena. That means you cannot really directly detect it with a satellite, for example. That means we actually have to dig and drill. So part of the sensors are in the ground and you don't see them on the picture here. They're 10 meters down in the ground collecting temperatures. And then there's a lot of other sensors above the surface that you can see here. These are weather stations. That's the type of stations that we have AWIPEV. But because we are at a different site, we need to collect them here directly where also the permafrost observations are. And why do we collect this complex set of parameters? Because we want to understand what changes the subsurface temperature regime. So we not only need to collect the atmosphere, we also do need to collect the changes in the snow cover, as well as the changes in the subsurface. And what, this is the wrong direction. Oh no, this flips back and forth. It's completely wrong. How can I be so wrong? I'm flipping the wrong button. So I will continue talk because this is these are the changes in the air temperature that we document. You have seen it already from Marion. There's a strong increase in the air temperatures. But what I want to show you with these pictures is that in the summers it's relatively mild at the area. The winters are also cold, of course, but you have what Marion also showed you. You have these events where you have positive temperatures in the winters. And what you also see with these shaded areas, so this shows you, the line shows you the mean monthly temperatures, and the shaded areas shows you the variability. So in the winter, you see this bar around the line is very much larger than in the summer. So strong variability. And this is the trend that basically also Marion already reported, strong temperature trend over the annual means. And what you can see, what we also know is what Marion said is that this is due to winter warming and also the warming that happens during the fall season. Okay, there was a lot of talking about the winter, the importance of winter. This is how it looks in the winter at the site. So we have the dominance of snow. And you can also see here some kind of new instrumentation that we added to the site. This is a sensor that measures automatically not only the snow depth, it also measures the mass of water, which is quite a novel instrumentation. And we can only do this because we have this great setup that we have an automated data transfer as well as a power line to the site, which then enables us to control the sensors also remotely, basically. And of course, as it is with every new sensor, you have to also check it in the field. And this is what we're doing here. At the field site, we're doing manual measurements to make sure that the sensor works okay. And also when we do this, we dig these snow pits, we take the snow density cylinder, but we also look at all the different layers in the snow. As you saw before, there's ice layers in there, which makes it hard to dig even in the snow. But very important for the permafrost is how this snow layer is, because how much snow is sitting on top and the characteristics of this snow determine how much energy actually goes into the ground. So the snow cover, it's dominant in New Orleans. This shows you again a picture of the 25 years of record of the monthly snow cover. And what you see is that the snow cover is really is prevalent there for almost the entire year. We have a short window of only 3 months where there is no snow. This is the snow cover, the snow-free period that you see here. And the alarming trend is that the snow mass is changing. So we have less snow cover there over the time period where we measured. And also the period where the snow is usually covering the ground is shortening by about 2 days per year. And you can imagine this is also part of the ecosystem, so animals live there. So this has also an effect on the entire ecosystem there. One important detail that was mentioned before are these rain on snow events. So this is only the solid part of the precipitation. We also measure the liquid part of the precipitation. And this is what actually looks like after such a winter rainfall event, rain on snow event. This happened in 2016, just after New Year's. Over a period of a few days, we had like 70 millimeters of rainfall. And what happens then is that the entire snowpack gets condensed or melted, basically. So you destroy this nice fluffy layer, you melt it, and then you have only water sitting there. And this water can refreeze again, forming these ice layers. And it can actually be very thick layers. So when we dig these snowpacks, the snow pits, we sometimes have like 5 to 10 centimeters of these thick ice layers in the snow or covering the tundra. This, by the way, makes it also very hard for the reindeers then, because they also try to get to the tundra. They cannot scrape through the ice at the bottom. And this makes it very difficult for them to eat, basically. So why is this important for the permafrost? Because if you have an ice layer or if you have a fluffy snow layer, it very much determines how much heat you get down there. And with an ice layer, it's more conductive than a fluffy snow layer. What effect does it have on the soil? So this shows you now the center record that is built, that are down to 130 centimeters depth. So they are recording temperatures at all these different depths over the year, every hour. And this shows you again a summary of the statistics, basically. So in the summer, you have warming. In the winter, you have the cooling. And again, in the winter, you have this high variability, which you have seen before with the air temperatures as well as with the snow cover. And what you also see is that the soil freezes and thaws annually, which means we do this every year. And what you can also see is that the freezing basically is delayed in some years, and that the thawing, and that sometimes it doesn't even freeze fully anymore. When I dug my first pits in New Orleans to establish this site, I could dig down to 90 centimeters. Below that, it's cement, basically. You cannot get down there with a shovel. When I dig now a pit, it's about 1.80. So we have about doubling of this upper process layer that seasonally freezes and thaws. And this also is shown in the temperature records. So when you see the statistics of these temperature sensors in the soil, again, for this long record, you see that it's everywhere warming. The red bar shows you the air temperature trend. And compared to that, you see the trends for every sensor in the soil down to 135 centimeters. And it's everywhere warming with different rates. And we try to understand now why these trends are different, for example, for the different layers, and for example, also with more depth, because we have a chain down there that is, as I said before, 10 meters down. So we also supplied these data to Earth system modelers and land surface modeler, because that really helps to understand these feedback processes that I explained before. Okay, so this is my last picture actually, and it's showing you my summary. So I really love working in New Orleans and in the Arctic, and this is a very special site, the AWIPEV site, because this has a suite of long-term observations. As we heard before, from the atmosphere, we have glaciology, we have the ocean, we have snow and permafrost. So it really helps to get this full puzzle to understand the complexities and the processes that are going on. And so AWIPEV is really like an exceptional stellar site for me, because it's one of the few sites in the Arctic that has all these instrumentations and people that work there with the same kind of theme. And with this, I would also like to thank the people who are here, who helped me set up the site, to maintain it during hard times. And yeah, many of you came today. Thank you for helping me. And yeah, that's it.
Thank you. And now to address the marine ecosystem, I would like to invite Dr. Benoit Le Breton, a CNRS researcher at the University of La Rochelle. He has been researching the fate of macroalgae at AWIPEV for several years. Welcome.
Thank you. So I'll try not to. Okay. So good evening, everybody. So we talked a lot about the Kongsfjorden. I'll try to, for the marine aspects, I'll try to show you, to like convince you that the Kongsfjorden is it's a perfect model to assess changes of ecosystem functioning. So we know that actually human societies are like facing challenges. Because we lose habitats, we have like the effect of global warming, the effect of pollutions, and that will lead to the loss of ecosystem functions. So these challenges are putting human societies at stake, because all these ecological functions which are provided by these ecosystems, the humans, they cannot replace them. So if we do lose them, we'll be quite into trouble. So saying this, you could ask me why going so high up in the north to assess these challenges. This is simply because, as it has been said, so I won't talk so much about that, as it has been said, the Kongsfjorden is one of the areas warming the most on Earth, especially because we have a very high connection between the waters in the fjord and the water coming from the Atlantic. So that makes the Kongsfjorden a perfect ecosystem model to assess the effect of changes on ecosystem functioning. So the change, of course, have to be considered, but most important after me are the dynamics of changes, because we all had witnessed changes in the world since the beginning of life. This is a simple process, or very complex actually, process which is called evolution. But acute changes can lead to collapses, to environmental crises. So when the changes are much too strong, then we can lose full ecosystems. This is what happened to dinosaurs a million years ago. So the question is, to what point can ecosystems buffer against changes until they collapse? And then until we lose major ecological functions that we cannot replace. Saying this, to understand changes, we have to understand the functioning of systems before. And these systems are like highly complex, tightly connected to land, atmosphere, and ice. That's why I'm quite happy to talk after my colleagues. And we are very lucky in the Kongsfjorden because we do have the station located close on the very right, close to all these systems and especially close to the fjord. So we do have to consider all these systems. Another thing that we have to consider when studying the marine ecosystems is that these marine ecosystems are like made of a diversity of habitats. Water, mudflats full of sediment, rocky bottoms, deep sea, and so on. All these systems, all these habitats are tightly connected to each other, meaning that if one habitat is losing an ecological function, it may affect all the other habitats, and we may lose some ecological functions at the scale of the ecosystem. That would be a major issue. So these interactions are related to flows of particles, to migrations of animals, birds, marine mammals, fish. And these interactions are creating these strong dependencies. So to understand the functioning of such systems, we do have to rely on a high diversity of scientific concepts, skills, and high-end technologies. And this is what we can get from this French-German framework in the framework of the AWIPEV station, because we do have like many projects which are managed by French and or by German peers. So I'll talk about one project I know well, which is and one ecological function that I know well, which is the provisioning of food sources. So if we look at rocky bottoms, we do have massive productions of macroalgae. These macroalgae, we call them kelp, and they are creating real forests. You can see on the picture on your right that these macroalgae, they can be up to 3 meters. So they are really creating forests, and they can have a biomass which can reach up 14 kilograms per meter square, which is huge. And thanks to the studies initiated in the long-term project called 6, this project was initiated in 1991, we can monitor the algae biomass. And we saw between 1996, 1998, and 2012, 2013, a very important increase of the biomass of macroalgae. So that sounds like we have more food sources for consumers. So the striking question to us was, are the consumers, are the inhabitants into the systems using these food sources? So that led us to the question to try to understand the role of macroalgae material at the scale of the entire habitat. So to do so, we do have to rely on trophic markers. I won't detail so much the methods, but I need to give you some very, very basics. So what we have to keep in mind when you use trophic markers is that we have to look at if food sources are close to consumers or more vice versa. So for example, this crab is very close to the potential food source. That means that this crab is relying on this food source. This crab is using this food source. The shell I'm showing on the picture is much too far from the food source in terms of composition. So that means that this shell is not relying on this food source. This shell is not eating this food source. So now if we look at the real data, we were able, by making measurements, to discriminate 3 groups of primary producers, so of food sources, the kelp, of course, some red algae, and some other food sources that we'll call mixed food sources. And we were also analyzing, determining the composition of consumers. And very surprisingly, we realized that these consumers were not eating at all the macroalgae. Meaning that these food resources in summer are not very useful as a food resource to the consumers. That led us to some questions, and we tried to understand if some other consumers from the fjord were eating these food resources. So we made some experimentations, and we have the experimental evidence that animals from some other habitats are actually using these food resources. Going from experiments to the field was the next step. So we decided to move forward. So the question we now have is to try to understand what is the role of this microalgae material at the scale of the full fjord. Again, because as I was telling you, we do have connections between the different habitats, especially in winter, because in winter, it's dark, there is no light, so there is no primary production, there is no growth of plants. So that leads us to the current project that we are developing. We are looking at the connection between areas which are producing organic matter, the rocky bottoms, this kelp forest, and the mud flats, with the hypothesis that we do have a trapping of food sources into the sediment. And then, if this organic matter is trapped into the sediment, that means that this organic matter is available all year long for the consumers living into the sediment. So to do so, we do have to combine classical ecology and high-end biochemical measurements. And at the very end, the aim is to understand if we do have a strong connectivity between different habitats in the fjord, and then to understand if we lose one habitat, at some point, if it will affect the other habitats or not. That's one example of what we are doing. So such projects, they can only be done in the framework of collaborations. So actually, this project has been developed in the framework of the project COLO6, which is supported by the AWI, the French Polar Institute, by the University of La Rochelle, the University of Bremen, and also the University of Malaga in Spain. But what I want to highlight here is that thanks to the support of these different institutions, we get either funding for students, either logistics, and so on. And this is really the combination of all this support from these different institutions which help us at carrying out these projects, which are quite complex to manage. I was talking about one example, but what I really want to stress is the fact that we are all working on different projects, and all together, these projects are making sense. So I want also to highlight some other projects. There are projects which are focusing on the extension of mudflats, so the changes of geomorphology of the coastline based on runoffs and releases of sediment. One colleague was talking about that before. It's very important because it's changing the shape of the habitats, changing the coverage of the habitats. But also there are many projects focusing on what's happening into the water column, because we do have lots of phytoplankton production in the water column. So some colleagues are trying to understand the processes affecting the water column and what are the stressors in the water column affecting the phytoplankton. Some colleagues are also focusing on the predators which are located in the water column, especially jellies, because jellies are actually developing a lot. The biomasses of jellies are increasing a lot into these systems. And the last project I would like to talk about, but there are so many that I could talk for hours, is a project which is the European project FACE IT, which is including human societies, and we definitely need to do that. Including human societies to develop strategies of co-management, to better understand these systems and to better communicate with societies. And we get back to the issues for societies related to the loss of ecological services. So actually the FACE IT project tries to do that, and it has been built thanks to the development of the COLO6 project. So there are many projects running. These projects are running because we do have lots of support from people for logistics. So I would like to really thank the people who are working at the AWIPEV station all year long, but also the people located in Brest, in Potsdam, and in Bremerhaven, because they are helping us a lot. And also I would like to thank Max Fanis and the AVI diving team, which is a huge support for our project. Thank you for your attention.
Thank you very much. We now have a few moments for questions still. If anyone has a comment or would like to talk further, all of the speakers will be joining us in the foyer for the reception. So you're welcome to continue the conversation there. But if we have some microphones available, if anyone has a question for one of our speakers, you're welcome to raise your hand and we will answer it as best we can. Yes.
Yes, thank you, Benoit. I have a question for Benoit. What about turbidity? Are there any measurements that are done into the AWIPEV frame? Because it seems to be important regarding the kelp, and also it can be linked maybe with the working team, which is from the glacier release, etc.
Yeah, that's a great question. I agree. So there are definitely measurements for turbidity. I think like Philip Fisher could answer this question much more. Like we have the chance to have like also an underwater observatory located at the AWIPEV station, and underwater observatory. Philip, you confirm me if I'm saying things which are wrong. They are making this underwater observatory is making many measurements. So all year long, available online actually. So based on that, we can have data from turbidity. So it's located close to the old pier. So we have the effect of the Bielva River, but there are definitely connections to build. Yeah.
Thank you very much. Any other questions from the audience? I was wondering, once again, sorry to put you on the spot, but with the kelp forests, even though you found they weren't a food source specifically, is there some other use or some other importance they could have?
So me again, sorry. Yes, definitely. That's the problem of like having very short time to talk. Like what I think is very important to keep in mind. Your question is quite right, actually. What I think is very important to keep in mind is that I was highlighting the importance of kelp forest in terms of food sources, but it's not because these food sources are not used locally that the kelp forests are not important ecologically. For example, the kelp forests are very important in terms of like habitat. You have many juveniles of fish, shrimps, small amphipods, and other animals which are like living into these systems. If we would lose the kelp forests because of an increase of turbidity, actually, for example, we would lose although the communities which are living into these kelp forests. And it's quite likely that the consumers which are into these kelp forests, like these small animals, these shrimps, small fish, and so on, like they are food for bigger fishes. They are food for birds as well. And so if we would lose the kelp forest, we would lose the habitat of these animals. And it's very likely that we would lose also the predators, the large predators, which are like so important to humans as well. So yeah, like that's one example of the role of kelp forests. There are many other ones, but it's not because they are not eaten that they are unuseful.
Thank you very much. If there are any other questions, we can grab maybe one more. Yes. Oh, yes, absolutely.
Yeah, thank you to our speakers. And Marion, I was intrigued by the winter data, the winter temperature correlation. You can almost draw the line to when it becomes above zero in wintertime, which is really hard to imagine for all the cryosphere in that region. Are there larger scale decadal or centurial processes that might interfere? So is there a chance that we will not be there when that happens, that there is a +0 degree wintertime Svalbard?
Oh, well, that's a difficult question. I cannot answer that right away. Sorry for that. So
and say you need 100 years more funding to answer.
Exactly, yes. As you are aware of, the IPCC predicts that the sea ice will completely vanish by the middle of the century, and then for sure the atmospheric circulation will react in some way to this as well. So yeah, there will be effects also on these cyclones traveling to the north, and yeah, but I cannot answer really. Sorry.
Thank you very much. Let's give one more round of applause for all of the speakers this evening. And now to commemorate the successful French-German cooperation at AWIPEV, the directors of the Alfred Wegener Institute and the French Polar Institute will now sign a joint declaration. Welcome.
I think we're supposed to say something too, yes?
You can say something.
I can say something?
I can nod behind you.
We want to have this fantastic interaction like Franck and Robert did. No, it's a quite moving moment, of course. It is really fantastic to have this short glimpse into the working together, the collaboration that makes all of this possible. And I was very moved by the way you described the beginnings of AWIPEV, that two directors had this idea what their co-workers should do. And then you started, and what comes out is a fully integrated, beautiful, also on the level of just human interaction, a beautiful thing. I have a small anecdote to tell. When I was a young director, just recently installed, and I went with a delegation visit to AWIPEV. We had this fantastic Saturday night evening in the bar, the get-together, the social get-together that you need for polar scientists to release the pressure of the hard work. And it was so much fun. We had a great dinner, there was dancing, there was all of this being together. And then at midnight, someone tapped on my shoulder, it was the Kings Bay coordinator, and said, "So you have to go." And Jérôme Chapelas, the director at this time, I also said, "You have to go." But everyone was dancing, and we were dancing, and we were looking at each other thinking like, what is going on? And then the Kings Bay manager said, "You are directors. After midnight, the staff wants to be alone, having fun." And we were thrown out to the cold outside, and we walked home a bit frustrated, because sometimes it is not the best to be director, but today it is fantastic to be a director for you, right?
It's very hard to speak after Antje. She always have good anecdotes. I'm afraid I don't have such a good one. But I would say really thank you for our speakers, because when I started as a young scientist, I was told two things. First, as we said just before, the climate change is happening, but it's going to be for the next generation. Bullshit. It's for us. It's now. And the second thing was, oh, scientists, you should learn to communicate because you're not very good at communicating your findings. I think today we had a proof that's not true. We had like very good communication. And I think the fact that, as people said, we are working all together in one place and exchanging things among ourselves means that we have this kind of nice picture, nice view of what is going on. And so it becomes, of course, easier to explain it. I'm not trying to diminish your value. I'm just saying this is important indeed to have a holistic view. So two messages. I know I'm the only one standing between the drinks and now, so I'm going to try to be brief, but two things that you should bring back with you when you leave this room is, first thing, what happened in the Arctic doesn't stay in the Arctic. So what we see here, or there, I should say, is what is going to affect us all. And so that's the message we should give. Most of the time people tell you, oh, it's in the Arctic or in the Antarctic, which is even worse. And they told us like, that doesn't concern us, or that's too far away, or when is that going to impact us? It is impacting us, and it is now. So that's the message to give. And the other message, gee, I don't remember it.
That you like Germans.
I got it.
You like Germans.
Of course I do. No, I remember it. She wants a drink. We are going to dance after, I promise. Of course. No, the important thing also is that climate change is due to humans. Humans are the reason for the intense climate change we're seeing. But you have also seen humans that are fighting it, humans that are really trying to understand it so as to better explain it and trying to find solutions, even if we don't have them now, Marianne, we will have them, I'm sure. So I would really like to say again what the others have said. Thank you, big thank you, huge thank you to all the people who makes this possible, from the time where we were not directors, where there were other directors, all the people who are in Brest or Bremerhaven or Potsdam and who are working hard every day. Some are in the room, so there were the speakers, but there are others that are more discreet, They are here for my team. I can see them. They are doing what people say, are not the big fancy or on-the-spot work, but which is so essential for things to happen. So don't hesitate to interact with them. And on that, I will thank you again for giving me the time to speak. Thank you.
So now, after 20 years of cohabitation, we will become formal.
Yes, formal engagement, actually.
And then we shake hands. So I'm sure the moderator comes back, but once more, this is all for you, the logistics who make things work together. Thank you, AWIPEV. Thank you, AVI Logistics.
Thank you very much. And it's not quite time for drinks. We do have a live connection with the station directors in New Ålesund, and they will be able to answer some questions from the audience and speak a bit about their experiences. Do we have them up on stage? Yes. Welcome. So welcome to the both of you. Perhaps you can introduce yourselves and tell us a little bit about what you do at the base.
Yes, hi everyone. I'm Isabel Schulz. I was the station leader from April 2022 until June 2023. And yeah, with that, I hand over to Fieke.
Yes, I'm Fieke Rader. I just signed 2 weeks ago the paper that I'm now the station leader at the moment until summer next year. Yeah, and we're very happy. Congratulations for the big milestone that you just signed.
Thank you so much for taking the time to be with us today. I'm curious, what's the weather like today?
At the moment, today it was very windy and snowy. It's around 0 degrees Celsius. The last days was, yeah, gray, not so good weather during the day. And magically the sun appears at 11 o'clock at night. At the moment, you kind of want to go to bed. So that is the status at the moment.
Now, how many years have each of you spent up in that area? And I'm just curious, is there anything that you miss from being further south?
So I've been staying now for 15 months on site, and sure, I miss my family, of course. And I do swimming a lot. I miss that kind of sport, and yeah, it's been nevertheless a super great time here. The scenery is awesome, and every day I remind myself where I am actually, and each day it's kind of falling in love with the scenery again each time.
Yes, I have been first time 4 months in New Ålesund in 2020 during the first COVID lockdown. Then I've been coming back for 15 months from 2021 to 2022 as observatory engineer. So also part of the overwintering team of AWIPEV. And now back. So I have had now about 20 months on site in total. And what I miss from being further south, I think it's less connected to the direct weather. Of course, it's nice when you can go out without too many clothing on. It's literally lighter. Here you always have heavier stuff on yourself. Apart from that, it's more things from a more normal civilization that I miss while being here. It's less the temperature. When it's summer here, I do get a strong summer feeling because the changes are so big compared to winter times and other times. So the permanent sun or the permanent daylight, the smells that come back from the tundra, the life that returns, that gives a summer feeling. So in that sense, I don't miss the classical, more southern summer.
Now, I'm wondering, do you have any strategies for dealing with the Arctic winters? I imagine that's quite rough.
So concerning myself, just actually still coming out of the dark season, which is approximately 3 months long, so it's 24 hours dark. I think always each season brings its charm with it. And you don't forget that in the wintertime, we have the Northern Lights coming up. And if you have a clear style, it's a spectacular scenery and it's nice to watch. And also in wintertime, we have much less scientists on site. So it's also time to reflect and bond more with the permanent staff, and also find some other activities like doing some knitting. And we also had in December, we had a Christmas market, and there I contributed with some self-made wooden cutting boards. And yeah, I was sold out. I had made 15. And so you always find something to do, something very enjoyable to do. So each season is very much nice. I don't know if you want to add something, Fieke.
Yeah, I totally agree with that part. I'm actually already looking forward a bit to the winter as well, because I really enjoyed the winter. In summer, I have problem sleeping. I have problem sleeping at the moment. And in winter, I have it less. So that is actually a big asset for me. I like the quietness, the calmness. You have the feeling of being a bit more remote. It's really nice that summer is so alive, but it is also sometimes a bit overwhelming because people visiting here are here for a shorter time. So they're full of energy. They want to do everything they can. And it's really easy to get along with that vibe, which is nice, but it also makes you tired. So that's really nice in the winter part, that you can calm down a bit more. Also that you connect then more with the people that are the whole year round on site, because in summer times, you are just connected with much more different people. So then you really have time to grow closer as a community on site. So I totally back up Isabel in that sense, that for me, it has many advantages and wasn't at all as hard as I expected in the beginning.
I'm wondering how many people are on the base now in the summer and in the village in the summer versus then in the winter?
At the moment, or in the winter, there are about 40 people in town. In summer, it can go up to around 120, 130. At the moment, there are around 100 people in town. So usually between April and August, beginning of September is the high season, with maybe a little break again, end of May. And then winter is clearly calmer.
And currently we have a lot of...
I'm curious about the wildlife around the station. What types of fauna do you see? Is there a polar bear population?
So currently we actually have a lot of bird scientists in town. So there are lots of geese coming, and they are laying their eggs, and these are actually quite attractive for polar bears as food source. So we do have some polar bears coming now around. Just today we got a call through the VHF saying that 2 polar bears have been seen 10 kilometers away from town. But nevertheless, they are quite fast in walking. So it's always good to have this kind of information and be aware that they are around. And yeah, then we can call also our scientists and call them back to the station so they are safe. And just today or just before, or when you started for this online conference, we have in front of our Blue House, we have a family of reindeers passing by. Now they have left. I wanted them to stay so you can see it. But it's really nice. We have sometimes the geese passing by and grazing, and sometimes the reindeers. Luckily, not so often the polar bears. And yeah, it's really nice to see the wildlife around us. And also very important to say, last year when I came, I was a tiny bit disappointed to not see so many whales around. And this year it's been fantastic so far. We had the last 3 days a big pot of belugas coming, 150 animals in the fjord passing by just in front of the harbor. And it just, you can see how excited I am about it. Blue whales in the fjord. And yeah, that's just really nice.
That's so amazing. I was wondering, would it be possible to turn your camera out the window so we can see what your view looks like?
I'm not sure if you can hear us.
Yeah. It's rather gray at the moment. So it's a bit of low clouds, which is kind of common in the summertime here. We do see the other side of the fjord, but I think the resolution of the camera is maybe not super good in that sense, or not strong enough, but yeah.
We got a nice view out the window. Thank you for indulging me. It looks like the Norwegian countryside, just a standard.
But
I was curious. They mentioned one of the speakers mentioned that there's one restaurant, or there's one kitchen that everyone eats from every day. What's that like? How is the food? Where's the food produced? Do you have a greenhouse or anything like that?
First question to answer, like the food, in my opinion, is really good. The kitchen it's a good team. They cook really diverse, nice meals. We always have a rather basic breakfast and then a big lunch, warm meal with also kind of a salad bar, and then a warm evening dinner. Evening dinner is really early at 4:30 to 5:30. That is the only downside. It's the Northern Norwegian culture that is being brought up then in that sense. And the food is imported. Everything is imported. So we have a boat coming in each 1.5, 2 months. It depends a bit. Usually each 1.5 months, and that brings us all the food. And it basically comes thus from all over the world.
Talking about greenhouse, so there's no greenhouse. However, I kind of started a little bit my own greenhouse, and from the fresh fruit I took some seeds from the pineapple, and now I have 6 pineapple babies in my greenhouse, and they're growing. So I will hand them over also to Fike, and she will take care of those.
That's so lovely. It's a big responsibility to take care of pineapples in the Arctic. So I wish you all the best in that challenge. We have some time for questions from the audience. If anyone's got a question for our friends in Svalbard, Spitsbergen, please raise your hand. We've got some microphones going around. Otherwise, I will keep asking questions all evening. Yes, don't be shy. Oh yes, we've got one there in the middle. You raise your hand again. Thank you. And we will ask a question, and they have to shift the audio over to the folks up there. So please ask your question, and then we will pause and allow them space to answer.
Okay. I hope you hear me well. Thank you very much for the presentation, and to all our presenters. Your colleagues told us that there were some synergies, that French and German had their own expertise, and I was wondering what was the expertise? How were you complemented in that? Thank you very much.
I think I'm not fully sure in what direction you want to lead the question, but I think it was two things in the beginning during the merging the two stations. There were the stronger, as Roland explained before, expertises in more atmosphere combined then with the more glaciology research from France. On site, it is at the moment more that France delivers some of the logistics. So AWIPEV has the boats, or owns the boats, the cars, and organizes in that sense more of the logistical part. Also delivers in that sense the logistics engineer, which is part of the team of 3 people that overwinters here on site. And then AWI, has other responsibilities in that sense. So it has more of the snow scooters. Like costs are being divided, the positions are divided. So with this, what I said is one person from AWIPEV as a logistics engineer, and then station leader and observatory engineer, which are more organizational and in that sense a bit more scientific as well, come then from the German side. So those are the synergies in that sense. Within the scientific projects, there are also many synergies happening. Those are more on the smaller scale, more on the, or not on the smaller scale, but more out of our scope in a way that it's depending per project who collaborates with whom, but a lot of collaboration is going on there between Germany and France, and also with any of the other institutions and researchers here that are here in town, belonging to other countries.
Yes. Any other questions from the audience? Yes, there in the back. You've got a microphone. Hi.
I would like to know, you get thousands of visitors in Ny-Ålesund over the next 3 months. Is there any interaction? Would it make sense if you would give lectures, explain what you're doing?
In terms of visitors, I think you mean tourist visitors. If yes, then we do get a lot of tourist ships coming in visiting Ny-Ålesund, and some of them we do engage with and explain them what we do. This is more for the guides who are on board, so they can relay the message from the town. But per se, it's not our task to engage more with the tourist community. That would be more on the guides. So we can touch base with them, but we can't go on each tourist ship and give lectures. That would be out of our scope. And just to give you an example, sometimes we have on a Sunday 4 ships coming in with approximately 200 passengers. And then on Sundays we are usually off, so we don't want to provide more information. What we do is that if some people know that we do launch the balloons, and then they approach us and ask, can we come? Can we watch the balloon launch? And then of course we say yes, and they are already then very satisfied to see that.
Are there any questions that you frequently are asked by these tourist groups? I'm curious what your FAQ is for the base.
Sorry, I didn't fully hear the question.
Sorry about that. I was wondering, among the tourists who come through, do you have any frequently asked questions that you have to answer?
Not really. Some are really for the moment holding back, but we have 2 electrical cars outside. They're called Goupil and Goupilette. And they have also French number plates. So all of the French tourist ships coming in, they recognize the brand and also the French number plate. And then they smile at us, see the nice car because it's kind of cute. And then there's some interaction but it's not, yeah, I guess it will increase throughout the next months, but so far it has been a bit quieter.
More there. Yes, another question from the audience.
I'd like to know how international exchanges are organized. Like I think you mentioned that other scientists also come. Where do they apply? Do you have sort of hotel rooms just for scientists? Do they have to tell you what they want to find out, or how is that organized? Thank you.
So the village itself, it's owned by a Norwegian state company called Kings Bay, and they basically rent out buildings to other institutions, to other countries. So we, as the French-German station, we rent Rabot, the Blue House, the observatory, and our apartments that are in other buildings. We rent them from Kings Bay. And then there are many other countries that I can try to call them all without forgetting one of them. We have the Italian station, British, Indian station, South Korean station, Chinese station, Japanese station, and Norwegian station. The Dutch station. Yes, no, I think I have them all. They all have their own institutions, like back in their own country, as we have AWI and AWIPEV, and they organize partly their own logistics, partly they rent things from Kings Bay. So, for example, the British station here does have a permanent building which they rent from Kings Bay, where they host some scientists, where they have some laboratories, but then they don't have their own boat, or they don't have their own car, and that then they also rent from Kings Bay. So it depends a bit per country how things are organized.
And in terms of visits, so if there's a delegation coming, we do have a hotel here. And it is then, depending on the delegation, if it's a German-French delegation, then AWIPEV would be the host. And we here at the station, we would organize to book the hotel and to book a charter plane. So this is always done and made via the stations. No one can contact the reception themselves and make a booking at the hotel. That doesn't work. That only works through the stations.
We got, a few more questions in the back. Who take your pick? Thank you.
Thank you. I'm curious how your day-to-day looks like as station lead, and you mentioned also observatory engineer. So what are you both doing, on your daily basis?
So daily basis is basically for us as station leaders, a lot of office work. But it also includes a lot of safety briefings for the scientists coming on site. And we are in charge of the rifles we have here at the station, and we have to hand out for the scientists if they are going in the field. So this is mandatory for safety reasons to carry a rifle for polar bear protection. And so we then give them a briefing how to handle the rifle. But of course, they also have to do some training prior to come to the station. And then we also check each booking from the scientists which want to come on site. So we have an accommodation plan. In total, we have 16 beds, and then we need to check when they want to come, if we have enough space at the station, and approve their booking. So this is also done through an online platform. And maybe Fike, you want to add up?
Yeah, like in terms of daily rhythm, we have breakfast, lunch, and dinner all at set times. So between those times, we work. After dinner, because it's so early, at least we often also work a bit, or still have to maybe to give a safety briefing to other people. And then there is a lot of opportunities for free time in the evenings as well. I can also add that we have duties shared among the team, which includes to check, like if I would be today on duty, it would mean that I would have to start a weather balloon to do a routine check of some other instruments, and to be on watch in the evening. Like during the day, it would be Isabel and me, knowing who is out in the field, making sure they have their safety equipment, making sure they're back on time. But we cannot be on duty 24/7 whole year long. So in the evenings and in the weekends, this is changed between the overwintering team. So this is also part of our daily or weekly routines to have those duties every now and then.
Thank you. Another question there in the back. Yeah, great.
Does the fact that so many people worldwide deny climate change, does that influence your work in any way?
I think on site, we are not strongly confronted with people denying climate change, like with the people themselves. We do have media outreach, which is also part of our job, like specifically also of Isabel, like of us as station leaders. There, of course, you can get more critical questions, maybe also like a question like this. But I haven't had often, or never actually on site, a moment where I was face to face with a climate change denier. So in that sense, it doesn't impact the work directly here. But I think in a more broader sense, you sometimes might have more general philosophical questions arising, seeing that the climate change is here so fast, seeing all the data that has been collected, that is being collected. We have so much knowledge about it, and there is not enough action taken. I think it's more on that level that it is in a way frustrating. But in the daily life, you're so absorbed here in everything that is happening. Life is busy. There is a lot of things going on, both in work and in free time. So you don't think about this factor of so often. In that sense, it's very, like I've been back the last half year, or between September and April, and there I was way more confronted with the fact there is climate change. Because you have a way bigger amount, diversity of people around you, you are more confronted with the media, and you make decisions yourself the whole time. Like here, all decisions you take are like many decisions about your consumption are taken for yourself. And back in Europe or on the mainland, you're constantly facing this because you have to care for yourself again. So in that sense, it's here more, in a way, it's easier to forget about it. Whereas you kind of see it happening here, but just because you're not confronted with how people have to solve it.
I think we have time for one last question. Yeah, there on the left, I saw a hand go up. Yes, there comes the microphone.
Hi, I'd like to know what kind of main activities you have at the station at the moment. What kind of guests? Any big projects running or just been finished or about to start?
So currently on site we have, we also support the Netherlands station logistically. So we have now approximately 5 scientists on site, and they're going out into the field looking at which kind of birds came back to Nyalesund. And then there's a French team of scientists. They are looking also at a different kind of bird, kittiwake colony. And then they are here for approximately 3 weeks, like the French scientists, and they are waiting for the birds to hatch. And then they're taking their samples, and then they will go back to their home lab and analyze the samples. And the scientists from the Netherlands, they stay approximately until mid-August. So they take the whole summer season. And then we have another team from Malaga here at the station, and they are doing marine biology, and they have long-term studies and some experiments which they're doing in the Kings Bay Marine Lab. And 2 of those scientists came already in mid-March, and they will stay until end of June. That's quite long. So they are already part of the station. And yeah, we have approximately 10, 12 people on site at the moment.
Thank you so much for taking the time to chat with us. Is there any last words that you would like to share with our audience here in Berlin?
Yes, I would first of all thank you for having us for this event. And yeah, we wish you now a very nice reception. And until next time you come to the station, I will for sure make sure you can dance until 2 a.m.
I back up Isabel.
Thank you so much to Isabel and Fika at the AWIPEV research base for joining us tonight. And thank you to the French Embassy, the Alfred Wegener Institute, and Reclim for putting together this event, and to all of our speakers for sharing their expertise, and to all of you in the audience here and on YouTube for joining us in this evening. And we would like to welcome you now to stay for drinks, some light bites, and a photo exhibition in the foyer. We look forward to meeting and exchanging with you further. Thank you and have a great evening.